Today we have to start from the topic that is 22.2, completing the square. So completing the square method is basically used to solve the quadratic equations by different methods other than the factorization method. When you cannot solve a quadratic equation by factorization, you can solve it using the method of completing the square, right? So it means that to solve a quadratic equation, we have another method, that is completing the square. Okay, quadratic expression in the form like x square plus 2ax plus a square. So this is a quadratic equation. So if we have a quadratic equation like that, so you can see that we can close the square, because this is same like at a square plus 2ab plus b square. So this type of expression can be written as a plus b whole square. So in this question you can see that we have the variable x and a, so we can write it as x plus a whole square. Do you understand?
Yes.
Again, if we have a negative sign with this central term, that is 2ax, so again we have another formula, that is a square minus 2ab plus b square. So then we have the formula to close these terms, that is a minus b whole square. Do you understand? So these are the two
Yes.
formulas which we have studied in previous classes and previous uh, according to your previous knowledge, are called perfect squares. So these are called the perfect squares because we make these expression in the form of squares. Okay, you can just a quadratic expression to write it in the form like this one. So we can also write the quadratic equation in this way, like x plus a whole square plus b. So you can see that a perfect square plus a constant in this way. And what is b? A and b can be positive or negative. B is also a constant, so b can be added to complete the square, because in this expression we have something missing to complete the square. So we add and subtract the b into this expression to complete the square. So this negative b is into this square, and the positive b is given there. Okay, do you have any problem till this step?
No.
Okay, good. This is called the completing square. It means that if we have not an expression in which the square is completed, so we have to add or subtract something, some term, some values into this expression to complete the square. So this is basically our topic. Okay, so here is the example. You can see that factorize x square plus 12x plus 36. So we have to factorize this equation, expression, right? Again in part b, hence write x square plus 12x plus 40. So we also can write x square plus 12x plus 40 into the complete square, and also x square plus 12x minus 1 in the form of this one. Okay, so first of all, you can see that according to the previous knowledge, we can write the first term as x whole square plus as it is, and this 36 can be written as 6 whole square. Okay, so this is your first term x, this is your last term, that is 6. So we can write 2x and 6, first term and last term, and you can see that when we multiply these three terms, your answer will be 12x. Okay, so this can be written as x plus 6 whole square. This is the formula which we have studied in starting, that one. Okay, do you have any problem?
No.
Okay, so now in the part B, we have to write x square plus 12x plus 40. So first of all, we can see that we have recently solved that if 36 is here, then we can complete the square as x plus 6 whole square. So we split 40 into two terms. First term is 36 and second term is 4, right? So these three terms make the complete square, and this 4 can written as it is. So it will becomes x plus 6 square plus 4. Do you understand or not?
Yes.
Okay. Again, for part B, x square plus 12x minus 1. So you can see that here we want 36, that is positive 36. And how we can write minus 1 as a 36? We can write plus 36 minus 37. Understand? So when we add these two terms, your answer will be minus 1. It means that we have to replace minus 1 as plus 36 minus 37. So first three terms make this complete square, that is x plus 6 whole square, and minus 36 is as it is. So this can be written as x plus a whole square plus b. So what is a in part 1? A is 6, and what is b in part 1? That is plus 4. Again, what is a in part 2? That is 6, and what is b in part 2? That is minus 37. Understand?
Yes.
So this is your solved example. Again, you can see that hence is a method you can use to write a quadratic expression in the form of x plus a whole square plus b. So here is another example. Write each of the following in the form of x plus a whole square plus b. So this is your expression, x square minus 10x plus 16. So you can see that here we have an expression x square minus 10x plus 16, and in this first example we have clearly understand that there is the formula for the first term. That's why we compare the second and third term with this formula. But in this case, we have not any formula. So the basic method to make it like a formula is that we have to take uh, this term, that is with x, right? Its coefficient, that is minus 10. So we firstly divide it by 2, that is minus 5, right? Do you understand or not? Take the
Yes.
coefficient of x, that is minus 10, half it. What is the half of minus 10? That is minus 5. And also square it. When we square it, so the square is 25. So it means that we have to add and subtract 25 into it. Okay, this is the method to make a complete square. First of all, we have to take the coefficient of x, secondly half it, and thirdly take the square of the this half, and it will becomes 25. Then we add and subtract this 25 into this expression. It will becomes x square minus 10x plus 25 minus 25 plus 16 is as it is. Now this can be written as formula, that is x minus 5 whole square, right, according to your previous knowledge, and the rest terms are minus 25 and plus 16. So minus 25 plus 16 can also be written as minus 9. So this is the form which we have to obtain in this example, x minus 5 whole square minus 9. Do you understand or not?
Yes.
Okay, so it means that we can write every quadratic expression in the form of x plus a whole square plus b. So in this case, you can see that a is minus 5 and b is minus 9, right?
Yes.
Okay.